Okay, so strong acids. Strong acids completely ionize in aqueous solutions. And ionize basically means that the ions just break apart. So if you think about when we talked about like nomenclature, something ionizing, like if you had sodium chloride, it would ionize, meaning it would break apart, and it would break apart into its two ions. So it would be Na plus and then Cl minus. Same things happens with strong acids, and that's what we're talking about here. If you have a strong acid and you put it in water, it'll always break apart, okay? Another word for this is dissociates. And then again, that means break apart, okay? So HCl, it always breaks apart. So it's always going to break apart into its two ions. And we know H, if we look on the periodic table, it's in group 1. That means it's going to be +1. And then if we look at chlorine or chloride, it's in group 17. So it's always going to be -1. So every time you put HCl into water, it's always going to break apart into these two ions, all right? All of the strong acids do this. Great question. What are the strong acids? Well, here we go. Let's find out. So the 7 strong acids you're going to need to know are these, all right? You do need to memorize them. The good thing about this is once you know these 7, every time you see an acid and it's not one of these 7, then you know that it's not a strong acid, all right? These are the only ones that are going to be strong, all right? Okay, so let's talk weak acids, all right? So let's say you have something like HClO2, okay? Now, first thing you need to know is, all right, is it a strong acid? Well, we go back to our list, or eventually you memorize it, and you check, okay, it's not that, it was a 2. So this must not be a strong acid. So if it's a weak acid, that means it's not always going to break apart into H plus and then ClO2. It's going to do it a little bit, but it's not always going to break apart. So the way that we show that it doesn't always break apart is we use this double-headed arrow, all right? And you can write it like this, how I did it here, or you can do it like it's shown down here. Either way is fine, okay? The big thing is, if it's a weak acid, you have to use the double-headed arrow, okay? You can only write the single-headed arrow if it's a strong acid. All right, is hydrochloric acid a strong acid? Let's check the list. We go back, we check it out. Yep, it is a strong acid, so we're good. All right, so this would be a single arrow, and then it would end up something like that, okay? So weak, strong. All right, there is a chart for us to check how strong or how weak they are, but we're not going to worry about that quite yet. Okay, so number 3. Because of this, we use the double-headed arrows to show that the reaction can go in the forward direction, or it can actually go in the reverse direction as well, all right? And when the reaction reaches equilibrium, that means the forward reaction equals the reverse reaction. So every time this HClO2 breaks down into H plus ClO2 minus, every time it goes forward one to break into that, the same excuse me, at the same time it goes backwards one to make another one of those. So, weak acids. Let's take a look at this. How do we know which of these is the acid and which of these is the base? So a couple context clues. First of all, H2O. It can be an acid or a base. So you can't start with that one. You have to look at the other thing, all right? So let's look at the other thing. It's HF, all right? What do you know about things that start with an H? Yes, exactly. If it starts with an H, it's probably an acid. Now, I know what you're thinking. Well, water starts with an H. Yeah, I know, but water's special, all right? So don't worry about water, all right? Think about this one over here, and all right, it starts with an H. If we wanted to name it, well, all right, it's H and then one other ion on there, one other element. So it's binary, which means to name it, we would have to use the hydro and then its core, so fluor, and then ic at the end of it. So this would be hydrofluoric acid. Okay, so this is the acid. All right. If it's the acid, that means the water has to be the base. All right. Now, is it strong? Is it weak? All right. So then HF, we go back to our chart that you're going to memorize. We look. All right. It's not on here. So therefore, it's going to be a weak acid. So it's good that they used the double-headed arrows. All right. And now the next part is figuring out what the products are. So this is an acid. Acids give up H pluses, right? They produce H pluses. So what's going to be left over after the HF loses an H plus? Yeah, exactly. It's going to be F minus, right? Because it lost an H plus. Remember, it has to be balanced. So if you put these two things back together, you'd get that HF. All right, now what about the H2O? So the H2O gained the H plus, right? So now H2O becomes H3O plus. All right, and there you go. And you can check to make sure that this is balanced, and it should be, because all we did was we took an H plus from here and we moved it over there. So everything should still be balanced. Okay, so as it says here, anything that is not a strong acid, the ones you memorized, would be considered a weak acid, and you would need to use the double-headed arrow.